All right, now we're working into quadratic functions. All right, we're playing with the big boys now. When does the graph of a quadratic function open upward and when does it open downward? Central question. First of all, what the heck is a quadratic function? Well, we'll talk about that in a second, but let me show you some examples of some quadratic functions in real life. Maybe you've seen some architecture, maybe the bottom of a bridge where you see these curved lines. That's considered a parabola, and this here is a quadratic function. Maybe you've seen this particular sign from McDonald's. Now this gets a little bit crazy here, but just this first arc, or even the second arc, is a parabola, and it's a part of a quadratic function. Perhaps you've seen someone kick a ball into the air. There's something that pulls it back down and creates this arc. Maybe you've played this game before, Angry Birds, where you shoot this little bird who apparently is pretty angry and to break little things. This creates an arc as well. Maybe you've been on a roller coaster before and it's gone up and it's come down. Well, there's a certain way that it actually is created to make sure that it's stable and that it distributes the weight. Maybe you shot a basketball before and it takes a certain direction and it starts to come back down. So you've seen a lot of downward arcing type of stuff, but it's not always downwards. In our real world, we do have a lot of down because of gravity, but there are things that move up as well, and so you should know both. So let's do an example. Andrew threw a baseball in the air from the outfield. This is a real life example. Not that I knew that Andrew threw a ball, but the rest of this is true. The height h in feet after t seconds can be found by this equation. So here's this kind of weird equation, and just follow it along with me for now. Just copy it down. It says the height is equal to negative 16 t squared plus 40t plus 6. Later I'll explain to you that this negative 16, negative, something's bringing down the baseball, negative. Then this includes, we're going to add something to it. This is going to be considered your velocity. And then there's some start off point. 6 feet in the air is where the ball started from. But anyway, that's not that important. I just want you to be able to plug stuff in. Look, after 1.5 seconds, how far or how high was the ball? So I'm just going to substitute. Time is 1.5 seconds. I substitute that, just like here. I go ahead and do order of operations. Order of operations says 1.5 times 1.5, and then times it by negative 16. I get negative 36. 1.5 times 40 is 60, and then 6. Add everything together, and I get 30. What the heck does that mean? That means that Andrew threw the ball into the air from the outfield to the infield, if you will. Threw it in the air, and in 1.5 seconds, 1001, right? After 1.5 seconds, it was already 30 feet in the air. And it started to make its way down. Now, is that the highest point? Well, we can figure that stuff out later. But for now, we know that 1.5 seconds from the point that he threw it, 0 seconds, to 1.5 seconds later, it was 30 feet in the air. Awesome. And so if you knew the velocity, if you knew how hard you throw something or kick something or whatever, if you knew this number, you could use this as the gravity, and you knew how high or tall you were where the ball was released or kicked, you could actually figure this information out on your own. So the function you just saw is an example of a quadratic function. What is a quadratic function? It's a function with a variable with a power of 2. Okay, so let's take a look at some examples. Here's some real examples, some math examples of quadratics. Notice I've got y equals x to the power of 2, y equals x to the power of 2 minus 4, and so on. I got negative ones, positive ones, negative ones, more negative ones, positive. These are just examples, so go ahead and write these down as yes, these are quadratic functions. Okay, all of them have variables with a power of 2. That's the max that I want to see, power of 2. Here's some non-examples. These are no good, not quadratic. Y equals x to the third. This is not going to look like a parabola. It's going to start with this, and it's going to start to turn. This one is a linear function. Nope, that's not quadratic. Over here to the 5th power, nope, that's not the way I want to see it. Y x to the 4th power, no. So none of these work out because they're not to the 2nd power. I've got one more real life example for you to get down. This is kind of a cool one too, so you can maybe remember this one. Look, in the function h, where h is height in feet, equals 0.66 times d squared represents the distance in miles you can see from a certain height. So let's put that to play. Look, let's graph and estimate how far you can see from 600 feet. So imagine you're standing on the ground, or even actually, laying on the ground. If you pretend you were laying on the ground trying to see something, you really couldn't see very far, right? Your line of sight would probably end pretty short. But if you were 6 feet standing up, or you were way up above and you were 600 feet in the air, can we determine how far you can actually see if you're 600 feet in the air? All right, so let's make a table. And here's what the table looks like. Okay, don't worry, I wrote the function right here. Look, 0 feet, if you're right there at ground level, you're not going to be able to see anything. But 10 feet in the air, you'll be able to see, if you type it in, 10 squared, it's 100. 100 times 0.66 is 66. So if I'm 10 feet in the air, I can see about 66 feet in the distance. 20 feet, I just multiply times 20, times it by 0.66, 264 feet. 30, 40, all that there. So these are the different distances, right? 0 feet in the air, 0, 10, 66, 20, 264. The higher and higher I get into the air, the further and further I can see, assuming there's nothing in my way. If I graph this information, it looks something like this, and you can see that this is not linear, this is quadratic. It starts to move up, right? The further and further I get up, the further and further I can see up to a certain point. And now I ask myself, look, if I'm 600 feet in the air, how far can I see? So I kind of like draw my line and roughly estimate that's somewhere around 30 miles. I don't know if it's exactly, but if I'm 600 feet in the air, I can see about 30 miles. Again, assuming there's no smog or nothing to block your view, that would be the distance. It's pretty cool. And here's my last part. So real quickly, positive quadratic functions versus negative ones. Here's the main idea. Positive ones are just positive, right? Y equals x squared. That's a positive x squared. So you're going to see a parabola, like a little curved line that's facing up. Y equals negative x squared. It's going to be facing down. So the way I remember this is just think positive is happy, right? Imagine there's like a little face here, happy. Negative, they would be sad. Wah. So if you see a negative out front of the x squared, it's going to go down in shape, and this positive is positive. Okay, that's it for notes today.